I am Dr. Ramkrishna Ghosh, an Associate Professor of the Department of Information Technology of Haldia Institute of Technology. Today, our discussion is pipeline in machine learning. Machine learning pipeline. What is machine learning pipeline? Machine learning pipeline is a structured workflow that automates the complete machine learning lifecycle. It begins with data collection, followed by pre-processing and feature engineering. Then the data is split into training, validation, and testing sets. The model learns parameters in training phase. Validation phase, it selects the best parameters to tune hyperparameters and selects the best model. Then testing phase, it evaluates the performance of the model on new unseen data. Next, a suitable algorithm is chosen, trained, and tuned using cross-validation and hyperparameter optimization. Cross-validation is a technique to reduce overfitting. Cross-validation is a technique of repeatedly splitting the dataset into training and validation sets. The dataset is divided into k subsets. The model is trained k times. Then the model is evaluated using suitable metrics and deployed for real-world use. Finally, the deployed model is monitored, continuously monitored for performance and retained whenever necessary to maintain accuracy and reliability. Why do we use an ML pipeline? An ML pipeline provides reproducibility, automation, scalability, reduced human errors, easier maintenance, faster experimentation, and consistent pre-processing during training and inference. Inference is a process of a trained machine learning model to make predictions. What are the different stages of machine learning pipeline? There are 11 stages. First, data is collected, data collection. Then data pre-processing, handling missing values, outlier detection, exploratory data analysis. Exploratory data analysis is a process of visualizing, summarizing datasets before the model is trained. It helps data scientists make understand the data by make understand the dataset, feature engineering, pre-processing. Feature engineering. Next, feature engineering is the process of creating, transforming, selecting input variables from raw data to make the performance of the model. Data splitting. The data is split into training, validation, and testing sets. Then appropriate model is chosen. Model selection. Then model is trained using appropriate algorithms. Hyperparameter tuning. Select the best parameters. Model evaluation. And then model deployment. Model deployment is a technique of making a trained model available for real world use. After model deployment, model training and retraining. Model training involves continuously tracking input data quality, prediction accuracy, data drift, concept drift, which will be discussed later in later slide, and resource utilization. Retraining is the process of updating the model using newly collected data to improve the performance of the model. Difference between a machine learning pipeline and a workflow. Machine learning pipeline actually is a subset of a complete data science workflow. Machine learning pipeline mainly focuses on machine learning tasks. Workflow focuses on the overall business or operational process. Machine learning pipeline automates the machine learning life cycle. Machine learning pipeline subset of data science workflow. Our workflow automates end-to-end business processes. Machine learning pipeline goal is to build and maintain accurate machine learning models. And workflow goal is to complete an entire process efficiently. Machine learning pipeline is primarily used by data scientists and ML engineers. And workflow is primarily used by multiple stakeholders, including business analysts, users, and developers. Pipeline automation is a technique of automatically executing all stages of an machine learning pipeline, from data collection to deployment without manual intervention. The benefits of pipeline automation: faster experimentation, reproducibility, reduced human errors, continuous training and deployment. Concept drift and data drift. Concept drift occurs when the relationship between the input variables and target variable changes over time. Example, a fraud detection model trained in 2023 may perform poorly in 2026 due to changes in fraud patterns, because fraud patterns have evolved. Data drift occurs when the statistical distribution of input feature changes over time, while the prediction task remains the same. A customer age distribution changes due to a new marketing campaign. Difference between concept drift and data drift. In data drift, input distribution changes. Concept drift, relationship between input and output changes. In data drift, features change. In concept drift, target behavior changes. Data drift easier to detect, but concept drift harder to detect. MLOps. MLOps, machine learning operations, combines machine learning, software engineering, and DevOps practices to automate the life cycle of machine learning models. It includes continuous integration, continuous delivery or development, deployment, automated retraining, model versioning, monitoring, governance. There are various machine learning pipeline tools. NumPy, Pandas, SCI Kitlearn, TensorFlow, PyTorch, MLflow, Kubeflow, Kubernetes, Docker, and many more. I will discuss in our next class. I am ending here. I will be genuinely helpful for your help and support. If you like my content, you can subscribe my YouTube channel. I eagerly anticipate your positive response shortly. Today I am ending here. I will come back soon with update videos. Thank you so much for watching this full video. Please stay tuned.